All right, let's get started here. Welcome everyone to ninth week, I think it is. We're on module 9, so I'm assuming it's the 9th week. The semester is going by quick. We're almost to the end here. A few more weeks. I'm gonna have the final project available to you by next week, I believe, and I think it should give everyone enough time to complete it. I also want to see if I could do the application deployment module a little earlier than usual. And that's because Heroku is going to get rid of their free accounts. And if I don't have access to the free accounts, then I won't be able to go over that part, at least using Heroku. I could try finding another hosting environment, but I don't know if I want to do that this semester at least. They are going to stop their free account November 28th, so I think we should be okay there. I think that's before the application deployment anyway, so I think we should be good there. So at least for this class, I'm good. Looks like for the spring semester, I'm going to have to find another environment to host. All right. Before we get started, I'd be happy to answer any questions. Hey. Oh, looks like we have Roger. Hey there, Roger. Okay. All right, Jocelyn. Thanks for that. Okay, so I'm sorry I had to reschedule this the Zoom session for Thursday. Something last minute came up yesterday afternoon, so I just had to do it. So I'm gonna extend the due dates for the lab by a day.
There's only 3 participants today.
Looks like it, yeah.
So I had to guess at the link on the Zoom link because it doesn't actually say October 27th. I picked the second one. Maybe that's why. Maybe
it's not actually important which link, click which one you use. They're all going to join the same one, so that may be the confusion there. If I send out and something right now, it's probably too late. So I mean, anyway, this is going to be recorded, so it should be okay. Yeah, Roger, you're right. Because when you go to Zoom, it's only going to list every Wednesday. So
I guessed.
Yeah, you just guessed. But you could join. They all will join the same one, so it's not an issue. But I could see that there being confusion there. That's interesting. So it's thinking it's the November 2nd one, because I guess the one yesterday passed. So I wonder what's going to happen next week. Okay, that's something that I need to take a look at. All right. Okay, so what we're going to do today is we're going to continue on MongoDB, and we're going to take a look. We're going to go further into how to define our schemas. We're going to then learn about uh, indexes and how to add them to our schemas. We're then we're gonna look at more options of how to filter information. And if we have time, we're gonna go over the app structure for Node, and that would be it. But I don't think we're gonna have time for this app structure. I usually do this next week, so that's probably gonna be when we do that. So schemas, indexing, and filtering is what today is about. I'm going to go over a PowerPoint presentation first. And then from here, we'll jump to examples. Okay, so we're sort of going from the point we left off last week. Schemas. So we saw last week that schemas allow us to define the shape and rules of our collections. Schemas not only allow us to define these aspects, but they also allow us to validate our data as well. So this is the reason why we didn't go too much into validation on the server. Because what we do is we let Mongoose handle that for us based on our schemas. So that's the reason why I didn't really talk about validation on the server. The validation ensures that the data we store maintains integrity, accuracy, consistency, and quality. If we don't control data integrity, we can't rely on the data to be accurate and consistent while developing applications. Loss of data integrity makes it impossible to develop applications, since we can't make any assumptions of the data, such as the fields and whatnot. And of course, we saw that Mongoose gives us a great deal of control when it comes to designing our databases. As far as the schema data types go, these are it here. So the data type of a field defines what type of information can be stored in that field. And the data type option is defined using the type key. So we have a type of string, date, Boolean, object ID, which is that unique ID field or the key field that our each collection has. We have this X type, which can be any one of these here. We have a number. We have a buffer for binary info. We have arrays. We have the SMO 128 for high precision numbers. And we have the data type of map, which allows us to store key value pairs in the field. The below options apply to all types, and they can be used for any field. So we can make sure a field is required. So by setting the required field of our schema for that specific field to true, then if we go to store something in that collection, if that field does not have any information in it, it will be rejected. We can specify a custom get. So when we are requesting when we want to read our schemas or read a field, what we can do is we can apply some kind of formatting to that information before 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 it adds to us. So we can find that using a callback function for the get. We can rename field names as well if we like. We can set a field's default. So what this does is this means that if the information is not there for that specific field, then the default value that we assign to this field default would be applied. We can also specify a validate valid action. This is if we don't want to use the default validation that it comes with. And just like get, we have set as well. So when we want to assign some value to a field, if we have this set function defined, that value would go through this set, and then we can add things to it if we want. So these give us a great level of control when it comes to schema validation, as well as being able to control what information goes into the schema and what information comes out of the schema. These options here will apply to string types. So if we set the lowercase option to true, then all text in that field would be automatically converted to lowercase before it's stored. And the same goes for uppercase. We can apply the trim option by setting trim to true. Any spaces that we have at the start of the value and at the end of the value, they will be just removed. We can set an enumeration, and what this does is this restricts that text field to just certain strings. Okay, so this comes in handy here. We can also specify a regular expression. So this is for validation. Okay. So if we try to store something in that field, if it doesn't match this regular expression, then it'll be rejected. Then we have min length and max length. So the number of characters we could store in a string here. Okay. These options here below, these options apply to the number of field types. So we have min max here as well. Below this example below is of a user schema. So for example, a user might have a name. So we set the type of that field to a string. We make sure it is required, and we also make sure the name cannot exceed 30 characters there. Then a user might have a mail address, and again, that's a type string. We want to make sure it's required, and we want to make sure it conforms to a valid email address. So this is the regular expression that that is going to be used to make sure that this email is valid. We have a phone object here. Okay, so this is going to be an object within this user here. This object here has a field of location, which is a type string, and an enumeration, which means that this location can either be the string home or the string self. It can't be something else. It has to be something inside of this enum. And we have the actual phone number here. We set it to type string, and we have a regular expression to make sure it will match a US phone number here. And finally, we have this field when this record was created. We have a type of date, and we are setting the default of this field to the current date. So when we're creating this, when we're creating a single user, we don't have to specify the date it was actually created, because that's going to be filled in for us whenever we go to store this object here. Okay, so that gives you an idea of how schemas work. MongoDB, just like traditional relation database systems, support indexes, and indexes are designed to allow queries to be as efficient as possible. They are like the keyword index in a book. There are generally two types of indexes in MongoDB: unique indexes and non-unique indexes. A unique index will ensure that a field or a combination of fields are unique in a collection. And a non-unique index just serves to make the query more efficient. The ID of a collection is a special type of index, often referred to as a primary key. And there only be one primary key in a collection, but there could be more than one index. And Mongoose allows us to define indexes in our schemas at design time. And we're going to see that today. Okay, so this is how we define index here. On the left-hand side, we have a non-unique. Yep, so we are setting the name field, which is a string type, and we set index to true. That's it. So just by setting index to true, whenever we access our collection for the first time, if that collection does not exist, then an index would be created for you. However, it's important to note here that if this collection already exists and you try to add, you set index to true, a new index will not be automatically added at that time. So this setting index to true will only work when you don't have a collection and Mongoose goes to create that collection. So that's something to keep in mind. And here on the right, we have a unique index, and very similar to just setting index to true. You just set index and you give it an object of unique and you set it to true. So this will create a unique index. However, there's still one catch here, that this index is going to be case sensitive. So there is a case sensitivity strength that we could define here, and that is gonna determine how strings are compared for this index. So by default, that strength has a value of 3, which means that it's case sensitive. So if we want to make this case insensitive, then we set that strength to 2, and that's what we have here. So by default, a unique index will enforce case sensitivity for string types, and we can make indexes case insensitive by setting the collation options, and collation option refer to language specific rules for string comparisons. So here we have email again. That's the field. Type string. We create a index on this field. We make it a unique index, and we set the collation options to the current locale. Okay, and we set the strength to 2. This strength, like I said, by default is set to 3. So a strength of 2 makes sure that this is case insensitive. And for something like this, you want it to be case insensitive, right? Okay. Querying, filtering data. So perhaps one of the most unique aspects of NoSQL database system is when it comes to querying data. Mongoose has a rich set of methods that allow us to filter and slice up data the way we want. Since no query language exists for it like SQL, we use a series of JSON objects to achieve a similar outcome. We're going to see those here. So a query in Mongoose consists of various functions that perform a specific task. The main function filter, the main function to filter data is the find function. The find function is used to return documents that meet a certain condition. So for example, if you want to filter data based on an email field, we could use the filter string, and that would look something like this. So we use the find function and we pass it the object here. So this object is going to search the collection for all documents that have email of jholiday@gmail.com. So this finds documents based on email. We can also specify more than one condition. So in this second example, it's going to look for anything that has an email address of sbob@abc.com. And so this comma is an and here. And the enable field is true. So this find documents based on email and enable being true. So how do we do ORs ands? That's what we're going to see here. So here we can also add logical ands or ORs to our find, and this is pretty unique, at least how MongoDB does these. So if we want to OR more than one condition, we use this syntax here. So we have this OR, which is an array, and inside of the array we put the first condition and the second condition, and if there are more than one condition, two conditions, then we just add more here. So or condition, comma, condition, comma, condition, comma, condition, right? So the way this would work is it'll return all documents that have email of either jholiday or jsmith@bc.com. And similar with and. So this condition has to be true and this condition has to be true. And that looks something like this. Here you'll see that we can do this and in two ways. We can either use this syntax here, which has and, which is an array, or if you looked at when we saw the example on this slide, we see that by adding a comma, that also does an and. Okay, so this here will get the same result as using this. Okay, so how about to filter based on mathematical comparison, such as equals, not equals, greater than or equals, less than or equal to, so in some collection and not in some collection. So that's how these are done. So EQ. So for example, if we have a field called age here, and we want to return everything that has an age equal to Artie, then the find object will have this in the age object here, EQ 30. That's just how it works, right? And not equals, greater than is GT, greater than or equal to is GTE, or less than is LT, LTE less than or equal to, in. So if you want to check to see if the age is either 20, 25, or 30, we can use this in for that. And NIN or not in a not in a collection, which would mean that age age is not 20 and not 25 and not 30. That's what that would mean. Okay, so that's how that would work, right? So if you go back to here, right, and we compare this to SQL, we'll see that in SQL to do an OR, it would look something like it'll be where email is equal to, for example, jholiday@email.com, right? Or right, we actually use the word or in this case. Or email is equal to jsmith@abc.com. Right, so this in SQL, the condition to do what we have here in this or would look something like that. Right? And with this and, let's just add. Right? So this is the equivalent of that. All right. How about when it comes to sorting? So sorting is done using the function sort. And the way we can specify sorting ascending on a field or ascending on a field is by setting it either to 1 or -1, right? So if you want to, in this case, if we want to sort the collection by first name, we use the function sort. We pass it an object with the field that we want to sort by, and we pass it either a 1, right, to sort it as ascending, or a -1 to sort it in descending order. Upsets. So we might not want to return all the fields in a collection, right? We might just need 1 or 2 fields in a collection. So for that, we use the function select. The way we do that is we pass in the fields that we want and we set the value to 1. Right? So here we're saying select first name and last name, right? Again, the equivalent equal statement for this would be the actual select statement, right? Select, right, first name, comma, last name, and then you'll have from blah, 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 right? So this is in SQL, and this is how we do this sort of thing in MongoDB. Okay, and how about if you want to emit results? Oftentimes, you only want a subset of documents rather than the whole collection. With Mongoose offers a way to limit this data using the limit function. So if we pass the limit function 30, it only returns the first 30. You can also skip a set, so by using the function skip. So if we say skip 10, it skips the first 10 and it'll return what comes to that. And and also the limit and the skip can be combined. So with the combination of limit and skip, we can enable paging, right? So if we have some large election and we don't want to return the whole thing, we just want to return 10 results on each page, right? So if we are on page 1, for example, right, we would skip 0 and we would return the first 10. we're on page 2, we skip the first 10 and we return the following 10. Page 3, we skip 20 and we return the next 10, right? So this would be a page of 10 here. Each page would have 10 results. And these can all be combined, which is really neat here, right? So we can do all of these in one shot. So we have the find here, right? Which we can say, in this case, we want to return the collection where enable field is set to true. We can then select just the first name field. We can then sort it by first name in descending order. We can then skip the first 10, and then we can return the next 10. Right?
I have a question.
Yes.
Where we're skipping the first 10 and et cetera with the paging example, we can pass in values for that, right?
You mean?
Does that get hard coded in?
Oh yeah, of course, yeah.
Okay.
Yeah.
So like I could say for like page 2 of something that was records like 10 to 20, I could then go ahead and add 10 to 20 to get to the next set of 20 to 30 if I wanted to like create dynamic links or something.
Yes.
Okay, cool, thanks.
Yeah. So for example, we will actually see this here, but I could go ahead and show you that. So if we have our endpoint here, right? If we have an endpoint that looks something like, I don't know, server.com, API users, right? And we do a get request to users. We can pass in, for example, page 1, right? Or let's say if we wanted to return page 2, and let's say each page we want to get 10 results. So what we can do here is, of course, in our endpoint handler, we will read this page, which will give us a value of 2. And then if we want 10 results per page, then what we do is we will have, well, the thing I'll do is I'll skip the find, select, sort, and all that. So what we'll do is would have a skip, and the skip would be the value of this page, which would be 2. So it would be like request query page, right? That's going to be the value 2, and then we do times 10, right? So page 2 would be 2 times 10. So we skip the first 20 results. Actually, I think we should be skipping the first 10 results, not 20, right? So for that, we would do page minus 1. So that's what we would have to do there. Something like that. So page minus 1 times 10, so that we would skip that, and then we would get the next 10 like that, right? So then now we can pass in page 3, right? It would be 2 times 10, right? So that would be mean that we skip the first 20 and return the next 10. So that would be page 3. So yeah, that's the kind of thing that we do here. All right. Okay, so like I said, we can combine all these, and we can finally create what I call the ultimate get endpoint that will allow us to do find, select, sort, skip, and limit in our points here. So here, what we're doing is we're checking to see if the filter is a find, and if the filter is defined, then we convert it into an object, because we need it to be that we need this to object, because this find has to be an object. And then we check to see if the select is defined, and if it is, we convert it to an object. We see if the sort is defined, we convert it into an object, and then the filter, select, sort goes into the find, select, and sort. And then we can also read if we if you want to skip any, if you want any, and then we finally run it. And with this endpoint, we can now do a request that looks like this here, right? So we can put in, for example, we want to return whatever this is, where the first name is April, and we want to just select the first name field, and we want to sort it by first name, and we want to commit the results to 10, right? So we can actually pass in these objects here right in the URL. Okay, and we will see an example of this in a bit. Okay, so we're not going to go ahead and continue on the to-do application by adding a new schema, and we're gonna add some filtering to it as well. And like I said, I don't think we're gonna have time to restructure the application for today, but if we do, then I'll go ahead and go over that as well. Okay, so let's go back and review the to-do application we did last week. So if you recall, we first established the connection to MongoDB by using mongoose.connect. We then defined our schema here, and we set a single field here called task to a string, and we made sure that it is required. Then we created the model, right, which we then pass in the name of election here. So the to-do election goes here. And then if we wanted to read all, right, we use the function called find, right, and it's this function that we put filter object. And then this is to find all. So this is get all task. And if you want to get a single task, then we use the function find by ID, and that takes in the ID of what we want to find. And when we wanted to create a new task, right, we use the new keyword on the auto here, so new to do, and then the object goes inside of that, and then all we do is we just refer to it and use the .save, right? That would then save it into our election. Then if we want to patch, we use the function find by ID and update. So this goes ahead and finds something based on ID, and if that object is found, then it's going to be replaced with what we supply in this area here. Oops, I'm sorry, not that area. That object is what gets replaced. So this is the object that has what we want to replace with. Okay, and these are what we had to set. So by setting new to true, we make sure that we return the updated object, and we want to make sure the run validators is set to true. That way, these values go through our schema to make sure they are correct. Valid. And then finally, the delete, we use the function find by ID and delete. Okay, so pretty straightforward there. All right, so let's go into MongoDB and do some examples on the find function. So let's log in here. Okay, and if you recall, we created that, I think it was a testDB collection. Okay, so under Atlas, we're going to click on Browse Collections. Under Collections, we're going to go into our test DB. And I'm going to okay, we want to go to test DB, and this was the users collection that we created last week. I just created these two here. And I'm going to add a couple more fields to these. So let me do that. I click on edit, and I want to add a new field. So add a field after email. And I don't know, we'll set this to, I don't know, age. It's not really a good field to store in an election, but this is just for example, so it's okay. All right, we're going to set this type to a int 32. Okay, so I don't know, we'll set the age here. 230. Update. And let's update the age. Let's add an age field for this document. So again, we'll add an age here. We'll set the type to an int 32. We'll set the age to 25. And then let's add one more new document. So I'm going to click on insert. And the first field is going to be first name. And we'll do Mike Smith. Add a, oops, just first name. We'll add a last name, Smith, and then we'll add that age field as well. The age, set it to an int 32, and we'll set the age to 50. Insert. Okay, so we have 3 here. So let's give this a try. So I'm going to go up here to the filter options, and I'm going to add an object like that. And in this object, I'm going to put where the first name, for example, is Amy. So Amy. So let's start out with that first. So there's an object, first name, Amy. Hit apply, and we just get one there. Now let's remove this. So let's reset it. And let's do an and. So an and is going to look like this. So again, we're going to start out with the empty object. And that is going to be an array. So we have to add a colon. We add the square bracket there. And then we have our first condition inside of here. So let's say the first condition, for example, we want the age to be equal, let's say, to 25. So now, actually, let's not do that yet. Let's just do and here, first name is set to Amy, and so we put a comma, a new object, last name is Smith. Right? So again, and colon square bracket for an array, and then we have our first condition here and our second condition there. Right, so if we hit apply here, we should get 1, Amy Smith. However, we change this last name to Smith 2, right? We should not get this to come up because we don't have any that has a last name of Smith 2. So we click apply and we get 0 results. So that's the and there. Okay, let's reset it. So now let's do something where we want the age to be thin. So our goal is we want all users between age of, let's say, 25 and 30, right? That's what we want to do. All users that have an age between 25 and 30, which is going to return me and E. Smith. Right? It's exclude Mike Smith there. So let's do that. So here we're going to do another add like that. Actually, we forgot the first object, so it needs to be there. And the $sign and square bracket for the array. Okay, the first condition, right? We want age to be greater than or equal to 25, right? So if we recall how that worked, we put a colon there. We put another early brace inside of it, right? So then we use the GTE, right? GTE colon 25. Okay, so that was the first condition. And let's copy that. So we'll copy that, comma, and our second condition. So age is less than or equal to, so LTE. LTE 30. Right? So that's how it would look like. So and first condition where age is greater than or equal to 25 and age is less than or equal to 30. So let's hit apply. When we do, we should only see this document and this document. And we do. Okay. So this is how we alter things. Okay. So this filter here that you see is what goes inside of the find function, right? And the find function was here, right? So we can put that directly in there like that. Okay, so that's what goes in the find here. And if we leave the find function empty like that, then it returns all. right? It's as if we hit this button reset and we don't have anything defined here. So we get the whole thing here. Okay. All right, so let's create a user collection here. That's what we're going to do now. So I'm going to come down. Go down here all the way to the end. And we're going to create a new collection. So this is going to be the user schema at endpoints. Okay, so schema. This is the schema of epical user. Okay, so let's first create the user or a user object that we would want to store. Okay, so I just created an empty user object. And of course, a user should have a first name. So let's do April. Okay, so we want this to be required. We also want this to have a max length of 15. Okay, we have our last name. So let's say May. We also want this to be required. And we want this to have a max length of 30. A user has an email address. So we want the email address to be a valid email. So say April May at gmail.com. We also want this to be required. We want it to be a valid email. Also, we want it to be a unique index. And we want it to be a non-case or non-case sensitive. Okay, a user is going to have a password. So just say ABC123 for now. We want the user to have an address, and that address is going to be an object, and the address has a number. So for example, 12123 has a street. Let's say Main Street. It has a city. Example. And it has a zip code, say 91201. Right? A user might have phone numbers. So phone numbers is going to be an array like that. And let's create our first phone number. Each phone number is going to have a location. And we want the location to be either home, work, cell, or other. Okay. And then the actual phone number. Right? So for example, 333-333-3333. And we want this to be a valid phone number format. So we want it to be in this format, specific format. Right. So that's going to be, and let's say this user has two phone numbers. So one for home, one for cell. So we have another object here. And this one would be cell, for example. Okay. User might have nicknames. So we'll say nicknames. And we want this to be an array because the user might have more than one. So let's say, I don't know, happy or joy. We also want to know when the user was actually created. So we'll have a field called created, and we set this to the current date and time. So date dot now gets the current date and time. And we also want to control whether this user is enabled or not. So we'll have a field called enabled, and we set it to, in this case, true. Right? So we want our user collection to have a schema like this. Right? These fields, these set of requirements, and all that. Right? That's going to be our goal here. So let's now define the schema for this here. Okay, so this is going to be the schema for the user collection. Okay, so we'll create a new const. We'll call this user schema. And we'll set it equal to a new mongoose schema. Right, so let's start out with the first field. So we have the first name. We set that to an object like that. We set the type. This is going to be a string. We want this to be required. So required, true. And we want this to have a max length of 15. So max length 15. Right? We are following these set of requirements here, right? We want this to be required, have a max length of 15. And it's a string. Right? So that's how we would define the first name field. Okay, let's define the last name field. So again, this is going to be type of string. It is also going to be required. And this is going to have a max length of 30. All right. Now let's define the email address. Okay, this is going to be a type of string. This is also going to be required. We also want to set this to a unique index that's case insensitive, right? Required, valid, unique index, case insensitive. So let's see how that works. So we set the index to an object. So let me make a note about this index here. So index only gets created automatically for a new collection. So what this means that if you define your schema and you forget to add this here, if you forget to define your unique index, and you run your application and it creates this schema for you, and then you come back and you add this index, it's not going to add a new index for you at that point. So if you want to add that index, you have to do it yourself at that point. So this only gets created when a new collection is being created. Okay, so this index, we want to make sure it's unique. So we set the unique to true. We also want it to be case insensitive. So we set the relation to the locale. Oops. I can spell locale to en or English. And we set the strength to the value 2. Right, so this will set a case insensitive index. And then finally, we want it to be a valid email. So we can use a regular expression for that. So let's get a regular expression. So for that, we are going to go to the website regex lib reg x actually regex 101. Yeah, this one here. We'll click on the regular expression library here. We'll search for email. And we're going to have a lot of options here. Okay, let's use this one here. Okay, so this is the expression that we want to get. So we will select it or copy it. So let's get the regular expression from that point all the way to that point. Control C here, and I'm going to paste it in between two forward slashes. So make sure the forward slashes exist because you can't leave these out. So the expression goes in between that. But there's one at the beginning and one at the end. All right, and this was the regular expression for an email address. Make sure this is a good expression. So abc@abc.com. Yep, that looks like a match. If we forget the dot, actually
I
that's
have a
still,
question about that regular expression.
Yeah.
Normally I see things like /n/ whatever. But
Right.
this is different. What
You're right. This is in hex format, I believe.
Why is it?
So it's a
but
good
what-
question. Why is it in hex format?
I mean, it's impossible to read.
It is impossible to read. You're right.
So
Yes.
why don't they do the /n/?
For some reason, they put it in hex format. I can't. I don't know why they put it in hex format, but I think you're right. Let's go back and find one that isn't in hex format and use that one instead. So I just went by the number of up votes that these had. Let's see this one here. Wow, that's a pretty long one there. I see something in the chat from Marco. It seems that the person just really liked hex. It's yeah, I mean, they either like hex or maybe they use some other tool and then they converted it or something like that, and that's how they hit submit or something. I don't know. I don't want to use that one. There was one that was this simple. That's way too simple. Let's use, and this was the one that I use. Let's use this one here. Yeah, I think this one is fine. So this one is not in hex format, but it's still not easy to read, as you can see. But it says a pattern error. So this one apparently is not a good one. So let's go back and go check the regex lib one. This website here, regexlib.com. And search, we'll put email, and let's use this one here. Let's see. Yeah. So that's, we can use this one here. If we go to the, we put that there, then we get an idea of what it's going to do here, right? So that symbol asserts that the addition is the start of the string. So that's what that's for. And then we have the first group, right, which is the in the open parentheses, close parentheses right there before the at symbol, right? We have the at symbol here. So before the at symbol, it has to match what we see here. So it has to match A through Z, all lowercase, or A through Z, all uppercase. So it could be some lowercase letters, uppercase letters, 0 through 9, underscore. And apparently you can add a hyphen in there as well. I think that's what that means. And it matches the dot as well. So you can have a underscore, dot, hyphen in the first part there, right? And then we have group number 2, which comes after the at symbol, and that we have all this here, right? So if you have time, feel free to go through this and you can kind of get an idea of what it's going to do there. So if we do something like abc.def@gmail.com, that should turn green. So we have one match there. Let's see what happens if we remove the .com. If we just have gmail.com there, it's not a match. So this is, according to this expression, this is not a valid email address. Let's put the dot back. And let's get rid of the at symbol, for example, and you can see that's not a valid email address either. So I think this here is good. So let's go ahead and copy that one, and we'll use that instead. So let's go here and paste that in there. I have an extra slash there. There we go. All right, so that's going to be our email address. We have an extra slash there. You noticed? Okay. Okay, so that's our email. So that's done. So we'll set the password now. Password is a type of string, and this is also required. So we set required to true. And then we have the address. So this is how we create an object here. So we actually create an object. So we create the address object here, but we don't specify the type of this. We just put in the fields that go in there. So address has a number, and the address number has a type of string. That's how we do that. Put a dot there. We have the street. So that's, again, a type of string. The city, type of string, and the zip code, which will leave as a string as well. All right, so that's how that address looks. Now we have our phone numbers, which is an array. So the way we define a field being an array is with just the array syntax like that. So we actually create an array, and then we put the fields that go in there. So, oops, I'm sorry. It's an array of an object. So we put the open curly brace and close curly brace. So array of objects is what's going to happen here. So in here, each object is going to have a location field, which is going to be a type of string. We want this to be required, so we'll set required to true. Also, we said if you go back up here, the location can either be home, work, cell, other. So we can use the enumeration here. So we set enum to an array, and we put all the valid values for this field. So work, cell, other. Okay, so location is a string, is required, and it can only be either of these, home, work, cell, or other. Right, and then we have the actual phone number there, which is a type string. It is also required, so required equals true, and we wanted to match a regular expression. So let's find a phone number. A phone number expression. So I'll put US phone number, see what comes up. And this here is good, right? This is what we want. So let's get this expression. I'll use this tool again just to see how it works. Okay, so this will match where, let's see here. So the first part is going to, this 2 through 9 will match a single character in the range of 2 through 9, right? So this is the area, not the area code. This is the entry code, I guess, right? I think. Yeah. And this is not required, so you don't need that. And then after that, you have, it is, oh, no, I'm sorry. I got that all wrong. So let's go do this again. So this is just going to match a single number. So the a phone number apparently can't start with a number 1. So it needs to be either 2 through 9 for the first actual number. And then we have D2 there, which can be need two numbers there. We have a hyphen followed by 3 numbers and then followed by 4 numbers, right? So we will have something like 555, 555, 5555. That would be a valid phone number. And if we try to start with the number 1, it's not going to be a match, right? Because of this 2 through 9 here, right? So this has to be either 2 through 9. So that's going to be a valid number. If we leave out that hyphen, it's going to be a no match, right? So this is fine. So let's copy that. And that's going to be our expression. Put that in there. Okay, it's going to look like that. All right, and we're done with our phone numbers. Our next field is the nickname field. So nicknames. And this is going to be an array. I'm sorry, this is going to be an array of strings. So the way we define that is we set the type. It looks strange, but this is how it's going to have to be done. It's we put string in the array format like that. Okay, so what this is saying is this nicknames field is a string array. Okay, so that's how that's done. All right, and we have 2 more fields. We have the date when it was created. So the created date is going to have a type of date, and we also want to set the default. So because we don't want to have to set this date each time we create a new account or new user, because the date is going to be the current date. So we just set the default to the current date. And then finally, the last field is the enable field, which is going to be a type of Boolean. And we want the default here to be set to true, right? Because when we create a new account, we want this to be turned on. We want it to be true. And then we can always change that after. All right, so this is our schema for a account that would have these fields here. Okay, so now that we defined our schema, let's create the model. We'll create a constant. We'll create the user model, mongoose model. We want the collection name to be user. So I'm sorry, users. So we put user for that. And we pass in our user schema. All right. So let's now create our CRUD endpoints. And what I'm going to, let's see here. What should I do here? Yeah. Let's just save a little bit of time, and I'll use these CRUD endpoints that we had for the task app. And we'll put that down here. And we just have to update these URLs. So API / we'll call this and these endpoints under the user URL. So we'll say API / user. So this first one, to get all users, we're going to just do user dot find, and we're good there. So this is going to be to get a single user, API user with an ID. Again, we'll change the to do to be the user there. And the rest is good. And to create a, I see a question. Okay, you just sent it to me. Okay, I think I can go ahead and read this. So, so we're saying, why did we put that string for the nicknames in the array brackets? Actually, let me go ahead and through that now, because if we see the object that we want to create, we want the nicknames, so it could be more than one. We want this to be an array, right? So we want it to be a string array, right? So we want to be able to store we want this nicknames to be an array. So to define that in the schema, right, we do it like this. So we put type. We use that square bracket for array syntax, and we put the type of array that we want, right? So this is going to define a string array. Okay, so that's why we did that, right? Because this field is not just a single string, right? It's an array. Okay. Right, so we did that. Read one user find by. Okay, that's good. Okay, so we want to create a new user there. API user and new user equals new user. Okay, and new user. And the rest is good. Okay, we want to update a user. So API user with an ID. user, find by ID and update. Good, 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 good. All right, that's all good. And delete user. Right, delete API/user, user, find by ID and delete. And that's it. Okay. So let's test these out. So let's stop this. And I want you to take a look at our collection. So if we take a look at our collection, you'll see that the task DB, which is the one that this connection string is for, right? This connection string that we had from last week has the task DB in there, right? So we are looking at this collection here, this task DB collection, which just has the to-dos schema in here. Let's refresh to make sure. It just has to-dos. So keep that in mind. I'm going to run the application now. So let's run it. And of course, we're going to get a bunch of schema errors. So let's take a look to see what's going on. Invalid schema configuration, true is not a value type. So I think I used a capital T for true somewhere in the schema. And that's why it's complaining. Does it tell me which line? Oops. Okay, true is not a valid. At path number dot required. Okay, number required. Where is it talking? What's it talking about here? At path number dot required. Make sure there was a string with an error. It's next to the match pink. Oh, thank you. Am I not seeing it here? There was a string with an error. Didn't see that string. Oh, it says line 180. Oh, right there. Thank you. Wow, that error, this error here does not match what's going on here at all. This is saying something about true not being valid for a number required. Oh, number as in the field name number. Oh, okay. Okay, got it. But it's talking about this required rather than this. Anyway. I got it. Yep. Okay, so let's try this again. So let's run it. And awesome. Okay, so we got no errors. Let's take a look at our MongoDB collection now. I'm going to refresh this. And you'll see now we have the users collection. Right? So it's not going to have anything in there now. But if you click on if you click on our indexes, we'll see that there is an index. Right? There is this email index. Right? And we see under here, it's unique and it's case insensitive. Right? So this index, this email_1 index got created from our schema that we defined, right? It came from this index here. Right? We set it to unique and we set the strength to 2. All right. So let's now test these endpoints. Let's use let's see, what tool should we use? This or RecBin? Let's use RecBin. Okay, so our endpoint URL is going to start with this here. So I'm going to copy that. And let's close some of these. We don't need them anymore. Let's leave that open. Okay, so that's going to be our endpoint URL /API/user. Right. So the first thing we want to do is we just want to do a GET request. Of course, we don't have any in there right now, so we're just going to get an empty response. But this is just going to confirm that things are okay. Good. Right, so we got a 200 and an empty array. Right, we don't have anything in the user election. It's empty. So let's go ahead and create a new user. Right, we're going to do a host request, and we want the content here. Make sure the content type is set. And now we have to make sure we meet the specifications of our schema. So let's create an object here to actually begin with. So the first field, let's create the first name, right? So we said the first name. Let's just do April. Okay, and let's just try to create this user using just this first name field and see what we get. Okay, we got a status of 400, right? That bad request, and you see all these errors, right? These errors came from our schema that we defined, right? So what's actually going on here is when we save it. So if we go to our endpoint here, when we're saving this, when we call the new user .save, before it stores it in MongoDB, it's gonna compare this object that the client sent against our schema that we defined here. If there is any kind of problems there, then it's not going to get stored, and instead this error is going to be defined. So then we have this if statement here. So if the error is defined, then we are returning the status of 400 with that error object. And that error object is what we're seeing here. Okay, so this object is this error object here. Okay, so it's saying that we have a field here that is required. So password is required. We have a field here that says path email is required. We have last name and path last name is required. Right, and then at the end here, we have user validation failed. The password is required. Path email is required. Path last name is required. Right. So we need the last name and email. So let's go ahead and do that. We'll set the last name to say Smith, and we'll set the email here. And the email now, let's not set a correct email. So we'll just do ABC. All right, so let's try it here. All right, so we got another 400 bad requests. And we have two issues here. One, we still don't have password field. So password is required. And under the email, it says path email is invalid, right? Based on the expression that we have in there, right? So what it's doing is it's comparing this ABC against our expression that we defined on this line here, right? This is not a valid email, so it's not going to be a valid response. All right, so let's fix the set password there, and we'll still have the error for this because we don't have a valid email. So let's fix the email, aprilsmith@gmail.com. And this time, let's put more than 15 characters for the first name. So we'll just add a bunch of Z's to the end of that. Okay, so let's try to save it. And we get another error. It says path first name, we scroll, is longer than maximum allowed length of 15. Right? And again, that's coming from our schema, right? When we set the last first name, we set the max length to 15. Okay, now let's actually go ahead and save it. So we'll do everything. So to just make sure everything is fine, let's send it now, and perfect. We got a 200. And this is the object that got returned to us, that got stored and returned, right? So as you'll see, it has the date and time created to the current date and time, right? That's because when we defined our schema, we put the created time to be a default of the current date and time, and enabled to also be a default of true, which is why we have enabled true, which we did not have to set, and the date and time created to the current date and time, which again we didn't have to set. Okay, let's take a look at our MongoDB collection under the users collection. Here it is, right? This is what we just created right now. Right? Okay, so we can now make sure our information we stored is in valid format, right? We don't I have to do validation, validate ourselves. We can just let the schema do it for us. Okay, so let's update this. So we will go to, well, actually, let's do a get request now. So this will return just one of these, right? We just stored one. Let's update this. So we'll go to patch there. And under patch, we want to update, right? So we want to set, let's set the address. So address, right? The address is going to be just like that. We have an address number. So we'll set the address number here to, let's say, 123. And let's just try to save this and see what happens. Okay, 404 not found. Okay, so the reason why it says not found is because we didn't pass in the user's ID that we want to update. Okay, so let's get that ID. So we'll do another get request. And this is the user's ID, right? So I'm gonna copy that. And in the URL, we're gonna do ID equals to that. And we want to do a patch request. So let's give this another try. Right, 404 not found. So we have a handler error here, it looks like. So let me make sure I type the URL path correct here, API/user. So let's see what's going on. Patch API/user. Okay, that looks right to me. Oh, I think I know what the problem is. I put ID equals in a string area. It needs to be part of the URL. So user/ and then the user ID. That's why it was saying it's not found. Okay, another try. All right, so it did save it, right? So we got a status of 200 and we have the number here for the address 123. I thought I set these as required. Did I not? The address? No, I didn't set them as required, so that's fine. Right? So we just said the address needs to have a number, or not needs to have, it can have a number, street, city, and zip, but they're not actually required. So as you can see now, this has an address and the number is set here for us. Okay, let's add a phone number. Okay, so we want to update again. Actually, let's not update. Let's create a new. So we'll do a post request. And under the post, we're going to have a first name. John. Last name. Smith. Email. Here's what we'll do now. Let's set the email to the same email as applesmith@gmail.com and see what happens there. And then we'll set password. We'll set the password to 123 ABC. Okay, and let's hit send. Make sure everything is correct. Post, correct URL. Okay. Okay, we got a 400, right? That request based on the index, right? So there was a problem with the that's here. So the problem is that we created a unique index for that field, right? And what this means is that we cannot store two of the exact same emails in that user's collection. So each user must have a unique email. That's why we're getting this here. Okay, let's fix this. So we'll do John Smith@gmail.com. And we got a 200, good. So what we'll do now is let's update John Smith. So we'll do a patch request. We're going to need the user's ID. So that's going to be appended to the URL like that. And let's set the phone number field. So phone numbers, right? That was an array of objects, right? So it's going to be an array of objects like that. So the phone number has a location field. So remember, this had to be home, cell, what was it? Home, work, cell, right? So if we try to set something that's not either home, work, or cell, see what ends up happening there. So let's just leave it at this. So phone numbers, we're just setting the location. Right? Patch, yes, patch, okay. Okay, we're getting bad gateway. Did my application crash? No. It went down for a second, I think. Let's try that again. Okay, we got a 400 again. So the first problem we have, the phone number is required, right? Path number is required. We didn't even set that here. And furthermore, you see we got another error here based on the phone number's location. It says ABC is not a valid enum value for path, right? And the enum values here are here, right? Home, work, cell, are there. So we have two issues here, right? One, we need a phone number, and two, this location is not correct. So let's fix that. Let's just say that's the phone number. And then we'll set the actual phone number. And let's just do, I don't know, 1, 2, 3, 4, 5, 6. All right, let's update. Another 400, right? Path number is invalid. Right? Because we set that, expression, right? We set the phone number to match this expression. So let's fix that. 555 hyphen 555 hyphen 5555. And we'll update it. And 200, and there we go. You'll see we have a phone numbers array of objects. We just have a single object in there. You also see that it automatically adds a key to that object, right? So the thing for that is because we want to be able to update this phone number. And to do that, we're going to need this ID. And again, let's check our collection, which is here. We will refresh. And here it is, right? John Smith. We have empty nicknames, and we have a phone numbers array with one object in there. Location home, phone number 55555. Okay. Okay, so we are running a little bit short on time here, so I'm gonna go ahead and work on this example here. So what I want to add here is the ability to do a search for a task. So I want a filter for search here. And I want a button that says find. Right, so if we have a bunch of tasks here, we can put a specific task name, hit find, and we just want that one task to be hit, the one that we actually try to do. So let's work on that. So the first thing I want to do is I want to change my get endpoint for all tasks, right? And that's this endpoint right over here. And for this endpoint, we just did a find to get all tasks there. So we're going to change this endpoint to look something like this. The first thing is we want to know what the URL of this endpoint can look like. So we're going to have a URL that might look something like this: API to-dos. We want to have a filter here, and this filter is going to be an object, and we want to be able to define the task here. So we want to be able to do something like task equal to, let's say, study. And so we'll add the ampersand. We want to be able to select a subset of the fields. In this collection, we just have one field, so we're not going to use this, but you can still include it. So the select is going to be an object, and this is going to be something like we just want the task field. So we put the task there, and we put the number 1. Right? That means include the task task field. And then we want to be able to sort these tasks. So ampersand sort equals one of the object here. and we define what we want to sort by. So for example, we want to sort it by the task field in descending order with -1 or just 1. Right? And we also want to be able to skip. So we'll have a skip here. For example, skip equals, let's say 10, ampersand. We want to also be able to emit these. So emit equals 10. Right? So we could have a URL that looks something like that, right? Which means that we want to search this task to do election for a task that is equal to study. We just want the study, the task field. We want to sort it by the task field in descending order. We want to skip the first 10 and we want to get X10. That's what that URL would do. So to be able to handle this URL, we need to make a change to our get endpoint. So let's do that now. So the first thing we'll do is we'll do a quick check. We'll see, is the filter object in the URL, right? So we do this if statement. So if request query filter. So what we're checking, is this filter in the URL? If it's in the URL, we want to convert it into an object. So what we'll do is we'll reassign this query dot filter to JSON dot parse, and we want to convert it into an object like that, because we can't put a string in here. Okay, something like this will not work. Right, this has to be an actual object, so it has to be something like that. Okay, so that's going to be the filter, and we're just going to do the same thing for the select and sort. So next if statement is going to be for our select. So query dot select, and select. And then next, we want to handle the sort. So query dot sort, and then we have the skip. Right? So for the skip, we'll do let skip, and we'll check if request dot query dot skip is defined. Then we will set the skip equal to int. We'll convert it into an integer. Request dot query dot skip, and we'll do the same thing with limit. So we'll say let limit if request query dot limit, not slimit, limit, and we will do limit equals parse int request query limit. Okay, so now that we have all these, we can change this find here to say find request query dot filter, and then we will do dot select request query dot select dot sort request query dot sort dot skip, and the skip goes in there, and dot limit, and the limit goes there, and then finally we execute. Right. So with this query, we can still just do a standard get request to that endpoint, and it will still give us the entire election. Okay, so let's see, should we give this a yeah, I think we should. So let's stop this and start it again. And let's add another task here. Add stopping. Let's add another one. Hiking. Okay. So now that we have at least 3 in here, let's give this endpoint a try here. So let's get this endpoint URL. Put that there. First, let's do a get to get all requests. API to-dos. Okay, so we have 3: learn Mongo, shopping, and hiking. So let's say now we want to do an emit of 1. So we just want 1, right? So we can now do limit equals to 1, and we should just get 1. We can set the limit to 2, and we'll get 2. What we can do is we can now skip 1 if we want. So we can skip first 1, and we can get the one that comes right after. So skip equals 1, and limit equals 1. So now we will skip the first one, and we get this one here. We can also sort it, right? We can do sort equals to, and then our object here. We want task to be sorted in descending order. We hit send, and we have in descending order. If we want to, if we want to reverse the order, we just set the task to the number 1, and we get in that order. If we just want the task field without the ID and the V here, we could do ampersand, select, and we can set the select to task and set it equal to the number 1. And this should give us, why is it giving us everything? Select task 1. It should only give us the 1 field. Sure I didn't. Select. Yeah, that looks correct. Okay, not sure why this one is not working. I'll probably have some mistake. So, oh, select is a colon. Thank you. Yes, select equals. Right. You have colon someplace, you have equals some other places. It's, there we go. Okay. So we still get the ID, so you can't remove that, but at least we don't have the V there, right? So we just have the ID and task there. All right, so this gives us a lot of, this gives a great deal of hour to be able to filter, select, sort, and all that with our endpoints. Okay, so now that we have this endpoint, let's actually make a change to this application to use it and to be able to just show the ones that we want here with that, with archability. All right, so let's go to the client. So the client is going to be in the public folder under index, and we want to add that search field. So that is going to go right under this unordered list here. under this unordered list, we want to create a div here with a class of, let's do some bootstrap. We'll create a form row with a top margin of 3. And in here, we want 2 columns. The first column is going to be a column of 9 units. And in that column, we want the actual search input. So we'll put an input here, give an ID of filter string, class form control, type text, and placeholder of filter task item. And then we actually want the filter button after that. So we'll put another class column of unit of 3. And we want a button with an ID of filter button, the class of button primary, and a type of button. We wanted to say find. Close the button out. All right, let's refresh. And okay, there it is. So we can now filter and then find. Okay, so let's handle this filter button here. Okay, so we will, let's do it. Let's put that right in this area. So let's make an event handler for that filter button. So filter btn on click anonymous function. And the first thing we'll do is we'll read this input. So we'll say let filter equals to jQuery, select by ID, filter string, dot val. And then we want to create this object, right? We want to create that filter object, the one that we put in the URL. So what we'll do here is we'll say let filter object obj equal to an object. We'll set task equal to that filter that we have, right? So this is going to create that object that then we're going to stringify and append to our endpoint URL. So it ends up with something like this, right? All right. And now what we want to do is check to see is the filter defined. So if we have something in here, then we want to use this filter object. If we do not have anything in there, then we want to get all. Okay, so that's what this if statement is for. So if the filter is defined, then we're gonna call the load to dos, which is right down here, and we're gonna ask it the filter object. If we leave it blank, then we just want to say load to dos, like that. Okay, so if there's something in here, then we're gonna of course create that object with that field, set the task, and then we're gonna pass that object into load to dos. Okay, so what we want to do here is we want to append, right, this filter object that's going to get passed into the load to dos to the URL. That's going to be the goal there. So we want to pass in that filter object like that. And then we want to JSON, then convert it into a string. So we're gonna stringify it. So we're going to stringify the filter object, and we want to append it. That, and forgot also filter equals to that, right? Filter equals to that object that we created up here. This object here. Okay. Okay. So there's another thing that we need to do here is because if we leave this empty and we hit find, it's just going to call load to-dos without a filter object. And if it does that, this filter object is going to be undefined. And if we try to stringify undefined, it's going to throw an error at us. Okay, so what we need to do is we need to set this to a default. So we could do that by just setting it equal to an empty object. Okay, so this is just a fault value of filter object if filter object is not included, right? If we call load to-dos with no filter object like this, then filter object is going to be set to an empty object. So we're going to stringify the empty object, and we're just going to get an empty object that looks like that, which is fine. If we do have this filter object, then that's the object that's going to be assigned. And then we're going to stringify that and append it to the URL. Okay. I hope that makes sense. Okay, so let's see if this works. So let's don't have to restart this actually. We can just do a refresh. Okay, let's type hiking and filter, and we just get that. Okay, if we want to see what's going on here, we can. So let's open this up in a new tab real quick. And now we are over right now as far as the time goes. Okay, we're going to go to the debugging under the network tab. Let's refresh this one more time. Okay, make sure XHR is selected so we can see all AJAX requests. Okay, so let's do hiking, find. Okay, this was our request, and if we select, we see that what's going on, right? We are doing a get request to this endpoint, and our filter object is right there, right? So we have the URL, filter equals to that object task, right? So we can actually get that URL, put it in rec bin, right? And we get that. And if we hit send, we should just get that one object. Okay, so that's what's going on there. All right. Let's end it here. Any questions? Can you repeat the last part after the undefined portion? Sure. The passing the undefined. Oh, yeah. Okay. So here's what's going to happen. If we don't put this empty object in here, let's see what will happen. Let's just do that. And let's refresh it. And we immediately will get an error. And what's going on is because when the application first loads, it's going to call load to-dos. But it's not going to pass in this filter object in this case on line 57. So we have an undefined object here. So this filter object is going to be undefined. The problem is if this is undefined, we're going to try to stringify an undefined. And that's why we're getting that error. Okay. So we will get an error if we just pass in load to-dos with no filter object. So what we do to fix that problem is we set a default here of this filter object to an empty object, which means that if we call load to-dos with no filter object, such as line 57 here, then filter object, instead of being undefined, it'll be an empty object. And if it's an empty object, we can stringify that empty object and we'll just get an empty object, right? We'll get something that looks like alter equals to that. And if we hit send, it'll then then we just get the tasks. All right. So that's what that's why I would like to do that here. Sure. No problem there, Marco. Are there any other questions? Any concerns, questions? Something not clear? Feel free to ask.
On the MongoDB website. Hello?
Yes. Oh, yes, Roger, go ahead.
And I noticed they had some charge, like so many, whatever, 12 cents per hour. But I'm assuming we're not going to get charged as long as we behave.
Well, it doesn't ask you for any edit card information, so they can't charge you either way. But I believe the imitations on it are, I think, storage is what you get. So you can only store so much in here. But no, you won't get any purchase for this.
Because I've actually had a MongoDB database for a year or plus now, but I never did anything with it, and I haven't gotten any emails except they're shutting it down because it's
That's good.
inactive. but they never said you owe this much.
No. Well, it's free to a certain extent. So what that extent is, limitations, that's going to be defined somewhere.
We can't be using it as a database for a million users otherwise.
I think you can, actually. I may be wrong, but I think you can. I think the only limitation is the amount of storage you can have, and you can only have one instance. So you can only have one collection. One, not collection. One cluster.
Because on AWS, a database can cost you anywhere from cents per hour to hundreds of dollars.
It gets up there real quick. I know. Yeah.
So,
yeah, that's a good point there. Let's see if we log out here. Take a look to see what the free version gives you. I'm sure there are more than one limitation here, so let's go to try free. Oh, it's not going to ask. It's not going to tell you here. It's after you actually sign up. Oh, here it is. The pricing, so shared. Let's view all plans. So I believe, okay, so the free one is this shared one. So up to 5 gigabytes. The RAM is shared, the CPU is shared, so it's not going to be that, it's going to be a much slower. You're only going to get a 2 gigabytes and 500 gigabyte deployments not available for free clusters. Okay, so I guess you don't get a backup, or if you do, it's not a full backup, perhaps, and you lose some of these here, elastic scalability, so you can't scale it, right? That's, I mean, it's not a problem if your application is small, but if your application grows and you have to scale it with this free option, you can't do that. Online archive doesn't have that. Admin API, that's very important. Private network, it's not important. Bring the LDAP integration, not very important. Yeah, you don't have that many limitations on it except for storage, like I was saying. So it looks like storage is mainly what you give, and you have it's going to be shared RAM and shared CPU. So speed wise, it's not going to be as fast, and you can't scale. So that's going to be the main
In,
thing there. So
in,
it's not that bad actually for something that's free. It's not that bad at all.
so in theory, would serverless work? Because then nothing is spinning up until we use it. So that's one reason why it's much cheaper.
You mean this option here,
Yeah.
the serverless? Uh,
Shared means it's active all the time. A serverless means it's not active unless we use it. Then it spins up, and there's a bit of a delay, apparently, like a 30-second delay. So that's
oh,
one
I
way.
see. So it'll actually out down if it's not being used, and
Yeah.
as when it gets access, it'll I'm back up again. Is that what how
Yeah,
that
that's one
works?
way to get. Yeah, that's one way. If Heroku offers a serverless solution, that may be free because it doesn't tax anything.
Oh, I see.
So,
The
but
name is a little misleading though. I don't understand why would it be serverless? It does,
we're like in like AWS offers AWS Lambda functions, which a server is not spinning up to serve. I don't know how it works, but you can, for example, write cron jobs, I guess, and it'll just spin up, do your job, and spin down. It's not on
oh,
24/7.
I get it. I see. So it's not your instance is not on a server kind of thing.
Yeah,
It's sort of
it's not on a virtual machine. It's not
I
running
got it.
24/7.
That's interesting. Okay.
So perhaps you can continue using Heroku if you can use if serverless stays free.
Right.
I don't know enough to know whether that would work.
Right. I see something Oslin, Oku shutting down its free tier. They won't help with migration. Yeah, they won't. I actually spoke with their CIO, I think he is, or the CEO. And he said that there is a free option through a service. I don't remember what the service name was that he said, but he said if you go through that service, you will get it for free as well. But you got to jump through some hoops there. And I believe this was only for students as well. So if you're a student, you can still use Heroku apparently, but you have to get another. You got to go through another service provider. He said the name. I just don't remember it. It's in. I think it's on this page here. Yeah, here, students. Here it is. It says we will be announcing more on our student program at Dreamforce. Dreamforce. I don't know what Dreamforce is. For our nonprofit community, we're working closely. Okay. So for students, they have this. I don't know this Dreamforce.
Dreamforce is in San Francisco.
Dreamforce, the conference.
Oh, it's a conference. Oh, okay. So
Yeah,
they'll.
I think it's the Salesforce conference.
Oh, okay. Okay. So they'll tell us about what they have planned at this at conference is what they're saying. Okay. Okay. I don't know why I was thinking that it was some Elvis or something like that. At Dreamforce. Okay, got it. So I guess they haven't yet, or they will soon. I don't know, but yeah, that's where that is. So apparently, if you're a student, you can still get get access. They just haven't come up with the way of how that access would work. Perhaps they'll do some thing where you have like like at student.laccd.edu or something like that. Then you might have that option or something. I have no idea, but yeah, that's what that is. Anyway, all right. Anything else? Oh, I got some pull up to the CIO. Yeah, well, the thing is, I said to him, I said that, we've been using this for class for the past at least 3 years, and students find it really ample to use. He's like, yeah, well, but he didn't really say why they wanna get rid of the free option. I'm sure it's not a good thing for them to have free things, right? I mean, it's not free for them, of course. So that's probably why.
They integrated with GitHub very well.
Oh, really? Did they?
Yeah. You load your data, put your code into GitHub.
Yeah.
And every time you upload, it goes over to Heroku. And,
oh, nice.
it's really nice. I have to I have to admit that.
Nice.
I'm the one who posted that the blurb on how to do it at Heroku. It's actually pretty easy, pretty straightforward.
Yeah. All right, everyone. Thanks for joining. Please let me know if you have any questions. Have a happy Halloween, I guess. I know I have two kids, so I'm gonna be out with them. And we'll be back. We'll be back next week. Next week we're gonna cover authentication. So that's gonna be final week for the server side. So once we finish authentication, then we'll move on to the client side. So then we'll end with that. All right, everyone. Great. I hope everyone has a great night and have a great week. We'll see you next week.
Thanks, Professor. Have a good night. Happy Halloween.
Thank you. Happy Halloween to you guys too. Bye-bye.